Alright, if you're getting ready for your HSC Software Engineering exam, then you have landed in the perfect spot. In this explainer, we're going to tear down some of the trickiest concepts from past papers and rebuild them into clear, simple knowledge you can actually use to crush your exam. Look, the secret isn't just about memorizing stuff. It's all about strategy. It's about figuring out what the examiners are really asking for and knowing exactly how to build your answer to tick every single box. And today, that's the strategy we're going to master together. First up, securing your software. Don't just think of these as exam topics. Seriously, this is the fundamental, need-to-know defensive playbook for every single person who writes code. So let's dive right in with a classic 2-mark question pulled straight from a past exam. Distinguish between authentication and authorization. Seems easy enough, right? But grabbing those full 2 marks, that takes precision. Okay, let's strip this down to the bare essentials. Just look at the slide. Authentication asks the question, who are you? Think of it like a bouncer checking your ID at the door. Then, and only then, does authorization ask, okay, now what are you allowed to do? That's your VIP pass. Getting that sequence right is the absolute key. So, when you need the formal definition for your answer, here it is. Authentication is all about verifying identity. Every time you type in a password, use your fingerprint on your phone, or get that little code texted to you for multi-factor authentication, yep, that's all authentication in action. The system is just making sure you really are who you claim to be. And now for part 2. Once the system knows who you are, authorization steps in. This is the rulebook that decides what you can actually get your hands on. You know, like in a company system, a manager is authorized to see and edit everyone's files, but a regular employee, they're probably only authorized to see their own. It is all about permissions. So, how do you take this and guarantee a perfect score? You just follow the examiner's mental checklist. Did you give a clear explanation for both terms? Yep. Did you properly distinguish between them, making it clear that authorization comes after authentication? You bet. And did you throw in some solid examples, like passwords and user permissions? Check. That right there is a full marks answer. So once a system knows who you are and what you're allowed to touch, it can start doing some really smart work. And that leads us perfectly into our next section, software automation. This is the intelligent engine that makes modern software feel, well, magical. Let's hit another common exam question, another 2-marker, this time on machine learning. We need to distinguish between supervised and unsupervised learning. And just like before, the name of the game is a crystal clear distinction backed up with good examples. You know, what's great about this is that it all comes down to a single idea, labels. Supervised learning works with labeled data. It's kind of like studying with flashcards, where you have the question on one side and the correct answer on the back. The machine learns from known outcomes. Unsupervised learning, on the other hand, is given a massive, messy pile of unlabeled data and just has to figure it out on its own. It's like being handed a giant box of Lego and told to sort it into groups without anyone telling you what the groups are. Okay, let's zoom in on a really famous algorithm, K nearest neighbors, or KNN. This little quote from an exam paper tells us everything we need to know. It uses existing, already classified or labeled data to figure out a new piece of data. And as soon as you see that word labeled, ding, 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 you know for sure we're talking about supervised learning. Now, before we even glance at any code, let's just walk through the logic. It's actually way simpler than it sounds. First, the algorithm takes our new unknown data point and measures how far away it is from every single other point it already knows about. Second, it finds the K closest ones. K is just a number we pick, like the 3 or 5 closest neighbors. Third, it looks at the labels of those neighbors and basically holds a vote. And finally, the label with the most votes wins. That becomes the prediction for our new point. Simple as that. And right here, you can see how that simple, plain English logic maps directly to the pseudocode. Every step we just talked about has a line of code to match. Step 1, calculating the distance. That's the loop with the distance function. Step 2, finding the closest neighbors. That's just sorting the list. Step 3 is grabbing the labels from the top K results. And Step 4, declaring the winner. That's using the mode function to find the most common one. See? When you break it down like that, it's not nearly as scary. Okay, so we've got secure software and intelligent algorithms. But how do you actually get a team of people to build something useful with all this stuff? Well, that's where we need to zoom out and look at the blueprint, managing the project. And here we have a big one. This is a 6-mark question, people. Compare the Agile and Agile software development approaches. 6 marks is a huge clue. It means they want details. They want you to define, discuss the pros and cons, and use a real scenario. So let's start with the bird's eye view. Waterfall is a hybrid. It gets its name from mixing waterfall and agile. You get the big, heavy, upfront planning from the old-school waterfall model, and then you bolt on the flexible, short sprints from agile. Pure agile, though, is iterative right from day one. It's all about short cycles, getting constant feedback, and being able to change direction on a dime. This table right here is gold for your revision notes. Wagile's biggest strength is that it gives you a nice balance between having a predictable plan and having some flexibility. The downside? If that big upfront plan turns out to be wrong and you need to make lots of changes, it gets really inefficient, fast. Agile, on the other hand, is born for chaos. It's fantastic when you don't know exactly what you're building yet. But its big risk is something called scope creep, where new ideas keep getting added without firm deadlines and the project just balloons out of control. Now, to really lock in those top marks, you have to apply what you know. So here's the perfect scenario for Agile, a mobile app startup. Let's say you release a new fitness app, and your first users are all screaming for a sleep tracking feature. With an Agile team, you can literally decide, okay, that's our top priority, and start building it in the very next 2-week sprint. A Wagagile team, they'd be stuck, they'd have to go back to their big master plan, get it approved, it would cause massive delays. That's why for fast-moving projects, Agile is the clear winner. So, you've got the knowledge, you understand the concepts, but just knowing things isn't enough to guarantee that top score. The final, crucial piece of this whole puzzle is your strategy, how you actually write your answer when the clock is ticking. It all comes down to this simple 4-step formula. Seriously, for any question that asks you to explain or compare something, this is your secret weapon. First, you define the key terms, nice and clear. Second, you contrast them, show how they're different, like we did with authentication and authorization. Third, you apply your knowledge with a killer example, like our mobile app startup. And finally, the most important step, check. Reread the question. Does it ask for an advantage and a disadvantage? Did you give them both? This formula is your guarantee that you won't leave any easy marks behind. And that's a wrap. Just remember, this exam, it's not just a test. It's really a stepping stone. You're not just learning a bunch of facts for a grade. You're learning the fundamental rules for creating things in our digital world. So the real question, the one I want to leave you with, is this. Once you've learned the rules of the code, what are you going to build with them? Good luck.